Okay, so before jumping into the engine, here is quickly all the steps we'll get through. The cool thing is that with all those separate steps, you will be able to use them separately on other effects. It's just those are kind of the base of VFX stuff you could do. And I think it's also worth mentioning that I got pretty inspired by this artist who made this fire effect, which is super cool, I think. I think it's done on Blender, and yeah, I went on a more for a more realistic look, if you see, and I used a sphere also instead of a cube. But yeah, that's a detail, and yeah, super cool stuff from this artist. And also concerning all the dissolve part, there's this artist who made a very cool blog post about how to do that. So I will cover that in this streaming session, but yeah, he made a very cool and detailed blog post. So let's switch to the engine. Okay, so I'm using Unity, and I'm also using Amplify Shader Editor, the VFX particle graph. And for the Ember part, like all the Embers going out, I'm using the VFX graph and all those small particles, the Unity shader graph. But all the things that are done in Amplify can also be done in the shader graph, the Unity shader graph. And and I'm also I'm on the Unity Universal Render Pipeline. So those are all the steps we'll cover during this streaming session. So let's start by this one. This is not really related to VFX, but what I like when I want to promote or show some of my work, I like to have a beautiful environment, and apart from the thing you want to show, in that case the fire, I also add post-process effect, and in this case the shading, a cool shading on that sphere. This is pretty simple. I think it's a good intro concerning all the thing I will cover, because when you do shader stuff, you're mainly manipulating numbers and data. So it's just those kind of things you are manipulating. So let's jump into this. Instead of using the classic shading like this, you would have I went for a half lumber shading or lighting. You can also, it's also called wrapped lighting. And what it does is like it smooths all the shading part, like you, instead of having the hard separation between the lighted part and the shadow part, it makes smoother gradients. And how I do that, like for the what we have now, it's a super simple world space light direction and the world normal and the dot product that outputs values between -1 and 1. I could saturate those, but here we don't mind doing that. And it gives that. So to smooth the result, I'm just remapping those -1 to 1 values to 0 to 1 first. And to do that, I just multiply by 0.5 and add 0.5. And as you can see, you don't have the hard separation between the light and the shadow part. And I just want also to share with you a super cool tool that helps visualizing the data we are manipulating, because I'm absolutely not a math guy, like manipulating formulas and stuff. This is not my stuff. But what I like is, like, I really need to visualize things, and Desmos, which is an online tool, really helps me do that kind of things. Back to this, yeah, here is the classic output. Like for 0, you have 0, 1, 1, etc. It's a linear curve. So this is what we have if we do the classic n dot light direction dot world normal. But what I did here is, like, I remapped those values. So we have this. So for a value of -1, we got 0. You can see, maybe I should this. Here we are at -1, and here we are at 1. And if I do that, at -1 we are just at 0, which is the darkest part. and at 1 we are still at 1, so it's okay. So this really shows how the values are remapped. And just after that, I'm using a power node just to change a bit the ramp or the gradient, and it looks like this. So as you can see, the darkest part is a bit more visible and more covers a bigger part of the sphere. And to see that, it's nope, it's this one. Let's hide those. And this is what we have now. Before we just had this, and now compared to the previous version, we had this, the darkest version, staying a bit longer, and then it goes to 1. And if we play with the power argument, we could input here this one. Like if I put 4, you can see that the darkest part is even more present in the curve. So just super cool tool to visualize things, but we'll get back to it just after when going in the other steps. So yeah, this was just the intro of the effect, because and I'm also adding the indirect diffuse light here, but yeah, this is quite trivial. And let's put back 2. And here we are. We have a good shading. At least I like this kind of shading, so I'm pretty happy with that. The next part, which is one of the most important part, is the area of the fire. Because as you can see here, we have this sphere, which is like telling where to put the fire and where to make the sphere burn. So for that, I'm using sign distance field, which is super useful when you do shader stuff. What are sign distance field? Those are kind of mathematical representation of shapes. Those can be 2D or 3D, and this is this is the most simple use case, like using a sphere. This is the most simple mathematical representation. And yeah, to do that, there are on the internet awesome resources from Inigo Quiles. I hope I pronounced it well. And he provides a lot of those functions to do tons of shapes. And those are 3D shapes. And I think that, yeah, there are also 2D shapes. And the outputs of those functions are the distance between the edge or the surface of the shape you are building. When we are closer to the surface, the value is closer to 0, and then it goes like just the distance between the surface. And you can see it here. Let's just switch to the other shader. For that, I'm using several elements. So I think I should start with the script, because I need to provide the center of the sphere and the radius, which we have here. So for that, I'm using a script. Let's open it. Okay, so let's zoom in. So the script is pretty simple, and as you can see, those are just, if I switch back to this, yeah, you see you have the mask script here, the material, and the volume. And the volume is just the transform I'm tracking to provide those data. So I'm just using the transform position, which is here. So this is the gizmo function. So for the material part, this is the volume position I'm transferring to the material, and this is the radius value, which comes from the transform scale. And I'm dividing by 2 or multiplying by 0.5 because I just want the radius and not the diameter. So yeah, that's all. That's as simple as it is. Just one important point is here I'm just providing the values using the set vector or set float or set color or whatever, but it will surely be better to use the material property blocks and instancing to avoid unnecessary draw calls. Because here, if I have several spheres being affected by only one or multiple volumes, mask volumes, let's call them, it will make a draw call because we are modifying or instancing each materials one at a time, depending on the values we are providing. So, and using material property blocks and instancing will avoid that. You will keep the same material, and it helps the engine to lower the draw calls. But yeah, here I just went for the quickest way. So now that we have the radius and the center, I'm just calculating the distance to the sphere using the radius and the position, and this is the rough output we get from the distance fill function. Like, just so you can see, I'm using this, like the position in world space and minus the radius here. Whoops. And this is what I'm doing here. And so yeah, this is what we have now. So this gives a cool area of effect, for example. And what I do next, I'm using the smooth step function again to remap those values, because the values coming from this part, if we do this, will only be like, how can I say? Yeah, the range is like going to the infinite. So I want to keep values from 0 to 1. And the smooth step allows me to do that because it saturates those values. And it also helps me remapping, like changing the gradient of those values. So let me show you. Like, I can play with that like this. So here we only have, there is no gradient anymore, just 0 or 1 value. And let's get back to Desmos so you can see what's happening. So let's imagine we are injecting values in there in the smooth. This is the smooth step function. So this is the output. If I just do this is what we get. Like if the incoming value is 0, I get 0 here, and if the incoming value is 1, I get 1, which is approximately here. And by changing the minimum and maximum value here, I just kind of remap everything. So if I do this, it's the same as doing this. So you can see it behaves really just the same. And yeah, this is how most of the time the smooth step function is. I use it to kind of change any gradient I'm inputting, whether it comes from calculations or values or just textures and stuff like that. So yeah. Oh yeah, and you can invert if you do it this way, like this. Whoops. And you can also expand, make something really smooth like this, but here I want to stay in a classic range. So now that I have the area of effect of the burning part, I can jump on the next part and make something more like give a burnt look, or like I don't know how to call it, like, yeah, something that is in a bad shape, I guess. And for that, I will use this gradient coming from those calculations and apply a texture and use a texture. So let's jump onto the next part. This one. So I kept all the previous parts just so you can see how the graph is growing. And yeah, I'll tell you at the end the super cool feature they have in shader in Amplify, which is the register local variable. Basically, what it does, it's really like when you are doing coding. It's just like saving values, so you can use those in other places. Like I saved my mask values here, and I use this value here. It avoids having a super huge mess, like having a spaghetti machine going on there and having tons of links everywhere. And for the sanity of all the people that will go through your shader and your graph, I really highly encourage you to use this feature. And I think there is no such such feature for the moment on the shader graph, the Unity shader graph. But there is this guy. No, let's close this. There is this guy who made kind of plugin that you can add, and it will helps you do. It will gives you that feature. So yeah, just this is on GitHub, available on GitHub. So download it before Unity. You can use it before Unity implements its own version. And I think for Unreal there is already this kind of feature which was just added not so long ago. So yeah, highly encourage you to use that because it's super useful and it helps organizing things and graphs. So back to the effect. So we want to use a texture and give a burn effect. So for that, I'm using, again, like I said, the gradient incoming from the distance from the sphere, like this. And I'm using a texture, and this textures, it's this one. For the moment, I'm just using the red channel, which was done using Substance Designer. Super simple. I just used the cloud noise from what I remember, and yeah, just making for the other channels some variations, so you can, yeah, for the latest part, the vertex deformation is not aligned. So, but it's not. It's just some other, yeah, random values. And to apply, like, let's just, whoops, do this. So this is the texture apply. And to apply this texture, I'm using a triplanar sampling method. It is super useful because you don't rely on any UVs. And what it does, it projects, this is a cool visualization of what triplanar sampling is doing. It projects the texture in the three axes, so XYZ, and blends everything based on the normal. So this is what you will have if you just outputs one axe, and when blended it gives something like that. So this is mostly used for terrain or stuff like that. Because for the terrain you cannot unwrap your whole terrain, especially if it's dynamic. So yeah, this is super useful also. But in our case, I should admit that this is not super optimized. Depending on the use case, you will maybe use another set of UVs, or you could use also the same guy with super awesome graphic stuff in this website. And yeah, instead of using triplanar mapping, you could use biplanar mapping, which is quite the same, but it's more optimized because it only does two texture sampling, sorry, and because it selects like you can see the difference, it selects the main directional, the most influenced directions. So the results are quite the same, but like for this part, you don't need to sample the one texture. You just need to sample one, like this direction. You just need to use this direction to sample the texture. So it's a small improvements. So yeah, but here again, I went for the fastest and simplest solution, but depending on the use case, there are other solution and features to use. So I'm just reading my notes. Also Keijiro did something similar for Unity. I think you just need to go on his GitHub and search for that biplanar mapping. So yeah, here no UVs, just the texture applied. And what I do to combine those texture information to the cloud, the gradient I have here. like this. What I do is I multiply those gradient values by 2, like this. So instead of having, you can see now that instead of having only a range from 0 to 1, we have a range from 0 to, like if I go here, like we have 0 here and 2, a value of 2 here at the very far. And next I simply subtract the values coming from my texture, the red channel, and it gives this. It's just like, you know, pushing the values a bit more so we can subtract and we don't go below 0. And next I saturate, because here when I do this, I'm again in the range of 0 to 2, but I want to get back to 0 to 1 because I don't want to affect my bloom post process, for example. And I saturate the values to get back to 0 to 1. And now you can see the values that were above 1 are back to clamped to 1. And as we saw before, like in this example, I'm again using the smooth step function to play with the sharpness of the effect. So let's just input like we had before, those minimum and maximum, and go to the material. Yeah. So as you can see, I can play with the gradient here, and depending on the effect I want to have, I can adjust those values and yeah, make the effect I want. Just remapping the values, I could invert it like this. And it's just to ease the pain of the artist that will use this material, I think it's always useful to, when possible, just lower the number of the properties you're offering to the people that will manipulate your materials. Because if you have tons of properties, it can become quite a mess. So yeah, and that's what I did when I just used, now if I output this here and this here, I just have a hardness value, and it does quite the same. Let's save it. And you can control it just with one property, so super useful. So now that we have a nice burnt effect, we can jump to something like more bloomy, right? Or just the ember part of the fire that it's getting over the whole sphere. Like if I move this here. So as you can see, we only have a few features here, but the graph is becoming a bit bigger and bigger. So yeah, again, promoting the register local variable. So yeah, use that. So the ember part, super small. And for that, I'm relying on what we had here. Like it's just a step-by-step explanation, and we are most of the time using the previous steps to continue. And so for this one, we are using this, etc. And for this, we are using those values. So I'm using another function, like another node, which is the distance node. I can jump again on this mouse to show you. So what does the distance node do? It compares two values, like in our case, the gradient we have here, to an offset property we input. I could do like this, but here for better controls, I'm using two properties, but yeah, just comparing two values and outputting the distance between, like, another value, which is the distance between the two values. For example, if I have a linear gradient, like the distance between 0 and 1 is 1. So This is what we have, and the distance between 0 to 0.5 is 0.5, etc. This is very linear, so nothing fancy in there. And so you can see, let me just output this. So, or maybe I could just output instead of the burn mask, like the volume mask here. So yeah, this is the great representation of what we have here. Like, yeah, so the distance here, we have an offset of 0, and the distance between 0, which would be 0 here, is 0. And it increases like this, the same way, like this. You can see it in both directions. Like if the distance between the 0 input we have here, like the offset, compared to this value is 1, that's why it gives that gradient. And it does the same, no matter what you input, it does the same with this input. If I lower the width like this. And by changing the offset, I can do it here too. You can see that it moves the gradient this way. And this is also what's happening in there when I do that. And I have also another property which helps me. Oh, I need to output this. Another property here that helps me play with the width of my gradient, like this thing. And for this, I have this. It's inverted here because at the very end I'm doing a 1 minus, so it's kind of flips the values, you know. So because I don't want, let's output this. I don't want to use a black value to apply the color, the Ember color. So yeah, I'm flipping those values. So yeah, and so you can see here the same behavior. Like if I have a very low width like this, the gradient is very small. And as we are evolving in this, or getting values from this gradient, we cannot go above those. See, if I push it, the maximum is this. I couldn't go above this. And the width here is also expanding this way because the limit is here. So this is that part that does this behavior. It's pushing the gradient to only one direction. It would be the same if I would be at the very start. Like, see, it's just an easy way of constrains the values between the specific range we have at the very top. So, and next, as I have 1 here for the bright part, I just multiply those values by the color, which is HDR, so I can push it above the range of 0 to 1. Like if I do, let's do this. So this is quite common. This is also used when you want to do some dissolve effect or anything related to something growing on a surface. So yeah, this is super useful. And next I'm adding everything, like to the burn part, I'm adding those values, and this gives something like this. And next, of course, you need to kind of tweak the values so it matches. If I do something like that, it doesn't look like any fire, or I don't know what it does look like, but yeah, not what we are aiming for. So let's make something like this. And as we are relying on this original gradient, it moves the same way as we move the volume, like the original volume mask. Next, another topic, because here we are just applying some changes on the colors, but now we want to make things like make some motion in there and have something nice moving. So this is done using vertex offset. This is again something you can use in a lot of situations and to do tons of effects, and yeah, super useful again and quite classic. So let's jump into the graph part. So I'm using triplet assembler 3 times. This is really bad performance-wise. this is not the good way to go. Again, depending on the situation, make a specific set of UVs to use those kind of features. But yeah, for that kind of effect, unless if you want something really procedural, and yeah, you don't have much choices. But yeah, it always depends on how and how you want to use those kind of things. Because yeah, in that case, this is, I admit it, I went for the simplest thing, and it's not the right way to go. But you could just input like text coordinate and use another UV channel like this. And I'm doing it 3 times because I want to sample each channel at a different offset. Like if I output this, you can see this is the red channel, this is the green channel, sorry, and this is the blue channel. And they're not going at the same speed because I'm just having an offset speed and multiplying just to give some random, like I could do, I don't know, like this. If I do 0. Whoop. Oh, okay. It's the time of scale. Okay. Let's put it back. Okay. So let's select the fire. So if I played with the speed, you can see that I just added a property to control the speed. So yeah. So yeah, back to the why I did it 3 times, because I want to have those values that cross each other and don't behave the same way. That's because to do the offset, the vertex offset, I use those 3 channels. Like the red channel controls the X values of my vertices, the green the Y, and the blue the Z. And that helps me offset the vertex position. So this is the values I'm injecting, I'm adding to the offset positions. Like if I output those positions, you can see it's just like if the pivot is at the center like this, you can see that if you look at the Y, so the green channel, it's above 0, so it's green, and below it's dark or black. So this is what we have right now. And if I output the vertex position added to those offset values, it just doesn't, it's quite subtle because I'm not pushing them super high, and I'm also constraining those offsets in the mask zone area, let's say. So it's not highly, maybe if I push the strength like this, you can see that it's not anymore very simple gradient. But here it just looks like nothing. We need to keep things like possible or realistic, I would say. So yeah, this is how just offsetting the vertices position by those input textures values. So yeah, Nothing fancy again. Let's just, yeah, let's do it this way so you can see. So, and of course, depending on the pattern you're using for the texture, it will offset the positions in a different way. If I use like a chess pattern or so whatever pattern you use, those will move in another direction. Because what I do here, let's focus on one channel and one direction. So this is the X direction. For the bright part, like the vertex position will be offset in the right direction, and for the dark, like black part, the vertex will be offset in the other opposite direction. And also something I should precise is that it does this from 1 to -1 directions because I'm offsetting or remapping the values provided by the textures. Like instead of, if I just do, maybe I can try something like that. Yeah, you can see that it's only going to the, like this way, because the values are not going in that direction because I'm constraining the offset only in a range of 0 to 1 because the inputs of the texture are from 0, the black parts, and 1, the brightest part. And as I want that it goes in both ways, like in every direction, I'm just multiplying by 2 and subtracting 1. So it moves it remaps the values so it goes in every direction. Maybe I can show you, yeah, in Desmos, I think I mean, yeah, this example. So this is what we have from when we have 0, it's 0, and when we have 1, it's 1. But when applying, like multiplying by 2 and subtracting 1, you can see that when having 0, it's remapped to -1. So instead of not moving or not offsetting, it goes yeah, in that direction, depending on, yeah, when you're looking at. But yeah, it goes in the opposite. And when it's 1, it's just 1. So cool way of remapping. Those are the two most useful remap and simple remap function to use when you want to change the range of your values in the range of 0 to 1. And yeah, I think that's all for the vertex offset. Yeah, nothing fancy here, just using the time and time values to offset the UVs, yeah, the fake UVs I'm providing to the triplenar sampler. So yeah. Next, we need to combine everything in that part. So this one is done. And yeah, this is the whole shader. It's not super big. I've seen a shader bigger than those, but yeah, again, using the register local variables helps organizing things. And here I'm just, let's select the material. I'm just playing with the values too, so it looks like I'm tweaking the value so it looks like what I want to achieve. Like I can, oh, I also added a cutout, but this is very trivial. I could just make it go like this. Whoops. If I want to keep, like, you know, a burn part at the edge, and maybe, whoops, just lower like this, just as an example. And yeah, it looks like this. Oops, the rotation is not needed. Then you have your sphere starting to burn, and it grows and it disappears. So yeah, I'm just here. I just used all the previous steps, like the volume mask, which is used in the burn part, the ember part, and then I'm combining everything here, like the lighting we had at the very beginning, which is multiplied by the burn part, like this part. Then to the result of that, I add the Ember, which is this. And let's keep the cutout for the end. And then I just used the vertex position offset to like change the position of those vertices. But and yeah, then I clip all the, if I remove this, I clip all the unnecessary part, because yeah, you don't want to have this black part, it's not needed. So I just put the alpha and the threshold, and everything is discarded in that area. So yeah. Also something worth noticing or telling about the vertex position offset. I forgot about this. Here I did, like, this is the offset result we have here. And I'm adding this offset to the original vertex position and outputting this to this output, because I selected vertex position absolute and not relative. Like if you check relative, this part, like those two nodes, will be done inside the amplify process or compilation process. But I like to do that manually, because sometimes I want to, do other behavior or change some stuff, or have the original stuff. So I like having hands on that part. So yeah. And also one important thing about this effect, it's that it obviously it relies on the triangle counts you have on your mesh. And here I went for again the simplest solution, so I'm using tessellation. But depending on your use case, you could use any other how can I say, any other way to control that triangle count. Here it's tessellating the whole sphere, but you could just tessellate the part, like we could constrain it to this part which is on fire, or you could use a higher biggest poly count for your mesh, depending on if you want to go on a realistic look or on a more cartoony look. Maybe I can show you how it looks if I lower the tessellation. Yeah, I think it's still believable like this. And if we look back to the example we had here, like for this example, as it's quite stylized, you don't need to go for a super high triangle count. But here I wanted to go for a realistic look, so yeah, I pushed the values a bit high. Yeah. Oh, and you could also use some kind of a hull mesh with only the parts you're burning, and inputs more triangles in there. There are always several solutions depending on your constraints, the platform you're targeting, and the look you are aiming for. So this is all for the material part and the shading part. Now let's jump on those particles that push the effect on the next level, I think. Because it's for me, it's the details are also super important, because it helps blending everything together and makes something goes to the next level and makes things more believable sometimes. So as you can see, let's see how this is made. But this is also affected by the volume we have here. And this is done. Let's close this if I can. Okay. This is done using the VFX graph from Unity. This is an awesome tool. And yeah, you can do super cool stuff. There are tons of examples on the internet, so take a look. I think Unity published you have access to a set of examples from Unity themselves, so take a look at those so you can learn from them. And yeah, also I think I already told you, but you will have access to those this project and other super cool project we made for this those streaming sessions. So yeah, take your hands on those and test, change, and try things. So Back to the particles. So for the particles, I won't cover that part because that part is just the same thing I did for the the area of the effect. So I won't cover that again. It's just using the sphere distance field and using those values. But what's interesting is the setup I have to emit those values in only that, only in the burning area. So let's look at this and outputs. I will just remove this and maybe I should zoom more so you can see. Okay, so let's just output everything so everything is visible. And let's put this on again. So as you can see, we have two types of particles. I have those white particles that are spawned only at this, whoops, in this area. And we have the amber here floating in the air. And I'm using those white particles to emit those embers or floating particles. And to do that, as I said, I'm using the area, and I'm constraining those particles in only this this thin area, and I'm using the distance like we saw before, and the step function. Let's remove this. This is all the particles. Oh, I need now to remove this. So this is all the particles that are scattered are on the mesh. This is a simple case because I'm using the sphere set position arc sphere, but you can use it on for simple meshes or skin meshes. So yeah, you can scatter particles on any shape you want. But I only want to keep those white ones. So to do that, I'm using the step function, like I said, to just have, it's like it's a if, like you'll do in a shader, like on-off thing affected by the width property here. Oh yeah, it's the particles. So if I change the width here, and what it does, it compares the gradient we have here. It's like the same thing we were looking at for the Ember part. And it says like, okay, if the value is lower or higher to the width value I'm inputting here, the width property here, it goes to 1 or 0. Just this is what the step function or node does. Sorry, and yeah, oops, like this. So for the center, it outputs 0, and for the values that are above 0.162, it outputs 1. And I'm inverting this because I could keep it the same way. I don't remember why I did that, but yeah, I could just keep those values. But I think it was feeling clearer for me to just have the white ones that stays and the black ones that are discarded. But yeah, you could just use this. So let's see how I'm using those to discard or remove those particles. So I'm just using the kill sphere node, and this is a bit tricky here. I think maybe with some custom nodes or a block, it will be possible to do it in another way. This is quite hacky, but it works well. So what I do, what does the kill sphere? I think there are also you can also use a box. But what I do with the kill sphere is like, sorry, get back to what does the kill sphere block does. The kill sphere, just like you put a sphere and everything in that sphere area is destroyed, or any particle that is in that area is discarded and destroyed. So what I do is like I use that to destroy all the unnecessary particles, and to do that I'm using a lerp to just kind of move this killing sphere. I just keep it very small with a very small radius, so it's like super tiny, and I'm just moving it from here and there, just like to destroy, like, okay, destroy this particle, this one, and etc., to destroy all those unnecessary particles. And this is done using the lerp function, because remember we had black values or 0 value here and 1 here, and when using the lerp, like for 0, I put my killing sphere at the same position of my particle, and that's how that, like, if I have the killing sphere here and the particle here, it's destroyed because it's inside the volume. So yeah, and I put it in the center if it's white, if it's 1 here. So, and that's how I'm destroying the unneeded, like the 0 value particles. So yeah, just simple and little trick to discard unneeded particles. This is super cool to, yeah, just keep things, keeps the needed particles. So let's put it back like this. And next, now that I have the positions I want to generate other those embers floating particles, I just link rate, like trigger event rate over time, and trigger those other particles like this. So this is quite classic, nothing fancy here. I won't cover that part because I'm just spawning particles and using some turbulences and forces to just move them through the air. Oh, and also I'm hiding those particles that are used. Oh, just to show you, I think if I could do that, and now it's emitting from the 0 or black particles, but if so this is not needed, and I would just have to like invert this, like put this, and it's also working, as you can see. So yeah, I don't remember why they did that. It's not needed. So yeah, bye. Okay, and yeah, remove the rendering of those, and now you have your particles emitting from some particles, and it's working. And just a quick thing about the shader that is used for those embers particles. Here I'm using the shader graph, and I went for the super fast way to do that, like just using the UVs, again distance field, but this time like sphere distance field, but in 2D. And the same thing we had before, like subtracting, and in that way using procedural noise, and this gives this shape, and outputting this shape to the alpha. So I don't know if I can pose it, and here it gives this, maybe this one, yeah, it gives those kind of shape. And as I'm relying on the UVs and a random value based on I think the particle ID or something like, whoops, what did I do? A random, yeah, I'm using a random number, so it offsets the noise, so I have different shapes here. This also depends, again, I think I'm always saying that, but this depends on your use case, because it's surely more efficient to use a texture or a set of texture. And I think Clement covered that, like by offsetting in a flipbook just to get random values. Yeah, it's really more efficient, or more performance wise, it's better to use that kind of thing, because calculating random values based on procedurally is super heavy. It has some, it's super cool and useful in some cases, but if you can, you should rely on textures when it's possible. So that's it for me. I hope that you liked this lecture, that you found this interesting and that you learned something. And see you next time. Bye.